Hey, so just when you thought that Unit 5 was done, well, think again. Review lesson. I thought that it would help you out a little bit to go through some questions, Regents questions, prior to the exam next week. So let's start with some review questions here, multiple choice Regents questions. First question says, what is the formula mass of aluminum sulfate? Okay, so formula mass, same thing as GFM, but different units. It's in AMU. So we set it up just like this. We have two aluminums, and we round the atomic mass to the whole number. As we see, our numbers are pretty much rounded to whole numbers here. So we have 2 times 26, and then 3 times 32, and 12 times 16. Where do these numbers come from? Well, I look at the subscripts, okay? There are 12 oxygens with an atomic mass of 16. Okay, everything on the inside of the parentheses gets multiplied by what's on the outside. So my answer is going to be roughly 342 when we do that. Now what I'd like you to do is maybe look at the question, pause the video, try to determine the answer, and then come back to the video. Number 2 says, what is the total number of moles of oxygen atoms present in 1 mole of magnesium chlorate? Okay, so we're looking at total number of moles, which is going to equal our number of atoms. So we say to ourselves, okay, how many atoms of oxygen do I have? I have 3 here, but it is multiplied by 2 because it's in parentheses. So 3 times 2 is 6. So 4 is the answer. Number 3 says, given the structural formula, what is the empirical formula? So let's look at the structural here. We have 1, 2, 3, 4 carbons, so we're going to say C4. Count all of our H's, 1, 2, 3, 4, 5, 6, 7, 8, H8, and then we have OH by itself. Okay, so we're going to say OH, and then there's 2 of those. Okay, so when we actually write it out, let's look at our answers. They don't separate, so we'll add up all of our hydrogens and oxygens. So we'll have C4, and then H, and then there's 2 here and 8 here, so it'll be H10 and 2 oxygens. We reduce this by dividing out by 2, so ultimately we will get C2H5O. Okay, so that would be number 2. I divided or simplified. Number 4, choose whether the reaction is exothermic or endothermic. Now, exo and endo, go back to the beginning of your unit notes when we talked about reactions. Exo means to release heat or energy, okay, and endothermic is to absorb. So in order to break a bond, you have to absorb energy, and when a bond is created, it releases energy. So we're going to look at our reaction here. We have H2S going to H2S liquid. Look at our phases. Gas to liquid. What has to happen in order for this to happen? When we go from gas going back down to a liquid, it's actually going to be cooling. Okay, so it actually releases heat. So in that sense, this is going to be exothermic. Now the next one, actually this question is going to be more of the next unit, so don't focus this that much on this. I honestly don't know how it got in here. We have a solid to a gas. So directly from a solid to a gas is called sublimation. We're going to learn that in Unit 6. And when you're going through that phase change, obviously you have to heat something up. So then it has to absorb energy. So this is going to be endothermic, and I'm going to just abbreviate it that way. And then here we have the sulfite with oxygen creating sulfate and heat. Okay, so heat is actually released. It is a product. So if it's released, then it's going to be exothermic. When you see heat on the product side, it's exothermic. It's actually been released as a product. So number 5, what is the percent composition by mass of nitrogen? Okay, so they give us our GFM, so this is going to be easy. We don't really have to do much. 80 is going to be on the bottom for our GFM. And then we just need to figure out how many nitrogens we have in the whole entire thing. So if I look at the formula, I see that I have 2 nitrogens. So it would be 2 times the mass of nitrogen, which is 14, okay, which gives us 28 over 80. And then multiply that by 100, which you should get, and bear with me here, I'm doing a calculation for you, 35%, okay, and that is a choice, so that would be number 2. Going back up, number 6, which balanced equation represents a single replacement reaction? So it's balanced, that's great, they're not asking us to do that, and we have to look for single replacement. So one element is by itself on the left, and a new element is by itself on the right. So let's look, I have magnesium and silver nitrate, and now on this side I have magnesium nitrate and silver by itself. I'm going to stop there because that shows me that magnesium was replaced with the silver, and now silver is by itself. So this guy goes in with this guy, and then that guy comes out. Okay? Everything else is clearly a different type of reaction. This is synthesis. Okay, you're creating something. The next one is decomp, because you broke it down into two parts. Decomposition, and then this one would actually be double replacement. I see two ions moving, magnesium going with the nitrate and silver going with the chloride. Okay, and that's exactly how you write it. The positive ion goes with negative ion. Okay? Number 7, when the equation is correctly balanced using smallest whole number coefficients, the coefficient of O2, so they only want to know right here. Well, let's balance this out first. We have CO2, so we have one carbon over here. I'm going to split it down. So carbons on this side I have 1, oxygens I have 3, and hydrogens I have 2. On this side I have 8 carbons, hydrogens I have 16, and I have 2 oxygens. So I have nice even numbers here. So it might be a little easier to work with this, but I need to get to 16 hydrogens. Let's start with the bigger number. So in order to get 16, I got to multiply this by 8. So let's put an 8 out in front of the H2O. So now that gives us 16 hydrogens and a total of 10 oxygens now. That's going to change, okay, because I have 8 here and 2 here, so that's 10. So now I can go back over here and say, well, I've got 16, I need 8 carbon. Oh, so now that's going to change this and my oxygens now as well. So now I have 8 carbons and 16 oxygens here and 8. So 16 plus 8 is 24, okay? 24 oxygens. I got to get 24 over here. So what times 2 gives me 24? That's going to be 12. So that's going to be the lowest coefficient for oxygen is going to be 12, okay? Number 8, an example of an empirical formula. Simplest form, guys. So what you need to look for a single element with no subscripts. Then it will be in simplest form. This has got subscripts, this one. Here we have one, HC2H3O2, but you have a total of 4 hydrogens, which can be reduced. So I'm going to say number 4, because CH2 cannot be reduced any further. If an equation is balanced properly, both sides of the equation must have the same number of what? We are talking about atoms, okay? That's what we're doing when we give coefficients. We're making the number of atoms equal to follow the law of conservation of matter, okay, as well as mass. Choose whether the reaction is exothermic or endothermic. I'm going to cancel this one, okay? We're going to skip that because it's not going to be on this unit test. 11, which equation shows a conservation of mass? Okay, so what we're talking about, same number of atoms on both sides. Is it balanced? Is it balanced? That's what you ask yourself. Okay, because balancing means conservation of mass, conservation of matter, everything is conserved there, and energy. 1 sodium, 2 chlorides, that's out. 1 aluminum, 1 here, 2 here, 3 here of the bromine, so that's out, it's not balanced. Then we have 2 hydrogens here, 2 hydrogens here, but I only have 1 on the left and 2 on the right, so that is out. 4 better be the right answer. Let's look. 1 phosphorus on the left, 1 phosphorus on the right, 5 on the left chlorine, and then a total of 5 chlorine on the right. Our answer is 4. Number 12, all chemical reactions have a conservation of what? It has to be everything, okay? Everything except basically volume, okay? Everything's going to be conserved. Mass, charge, and energy. That is what we're dealing with when we balance an equation. Okay, mass, charge, and energy. If whatever is absorbed has to be released. Okay. 13% by mass of calcium in the compound calcium sulfate is approximately, now they don't give us our GFM, so we need to calculate GFM. And let's do that. So we have calcium, which has an atomic mass of approximately 40. So that's for the calcium. Follow with me. Sulfur is 32. Okay. And we have 4 oxygens at 16 atomic mass units or grams per mole. So 16 times 4 is 60. I don't know what's going on with my pen today, guys. 64. All right. So when we add that up, we have 72 and 64 is going to be, just double check, 136, okay, grams per mole. All right, so that's going to be our bottom number, and then on the top is just the mass of the calcium. All right, so we're looking, and that's 40, and then we're going to multiply by 100. So 40 divided by 136 times 100 gives us approximately 29%. Okay, again, pause, try to calculate it before you actually check my answer. 14, copper has 2 naturally occurring isotopes. Information about the isotopes are given in the table below. I threw this in here because it's really important. It goes back to Unit 2, okay, for calculations of atomic mass, periodic table, and all that stuff. So what you need to do is, for this isotope, we're looking at the mass times the percent abundance in decimal form. Okay. So what we do is we convert this to a decimal, which is 0.6917. All you do is divide by 100. To get percent, we multiply by 100. To go back to decimal, we divide by 100. So our first thing would look at the first isotope. So we take the atomic mass, 62.93, and multiply it by the percent abundance in decimal form. So let's look at our choices here and see what we have. We have 62.93 plus that? No. Okay, that's going to be wrong right off the bat because we're looking for 62.93 times 0.6917. Okay, so this looks like a possible choice. And let's double check. 64, same thing for the second isotope, and then they get added to each other. That gives us the WAM, if you remember, weighted average mass. And this actually looks like the correct answer. 0.3083 is actually 30.83%. Okay, so the answer is 2 there. Last question for multiple choice. In which compound is the percent composition by mass of chlorine equal to 42%? So chlorine has an atomic mass of 35, okay, approximately. So we're not going to use any decimals here. Makes it a little easier. 35, and they give us our GFM. So what we're going to do is just plug in 35 over all of these different GFMs to figure out which one comes out to 42%. So 35 divided by 42 times 100, and I'll tell you right now that's 83.83 times 100 is 83%, so that one's out. Okay, then we look at this one and we say 35, and I'm just doing scratch work here. 35 divided by 68. I won't even multiply because I'm just going to tell right off the bat. This is 0.51, which if I convert that is not 42%. Next one, I have 35 out of 84. It's really sloppy. 35 divided by 84 looks like 40 point, well, it's going to be 0.417, which actually rounds to 0.42 times 100, and that is going to be my answer, 42%. Okay, so this is the correct answer there, and then you don't have to go any farther. All right, so I threw a little calculation one in here for you guys, a mole-mole problem, which in this case, we need to figure out our ratios of moles and mass in order to answer the questions. So first we're going to look at our moles, make sure it's balanced. The equation is balanced already. So for moles, we have 1 to 3 to 2 ratio. Okay, for all reactants and products. Our masses then, we have to go in and figure out. We have 2 nitrogens at 14 grams per mole, so that's going to give us 28 grams. And then we have 6 hydrogens, which is about 6 grams. And then that is actually going to equal, if you think about it, here's the conservation of mass right here, 2 times ammonia, okay, the NH3, same amount of molecules or atoms, so our mass is actually going to be just the total of 28 and 6. So we conserved mass because as long as we have a balanced equation, we're conserving mass. All right, so now we can determine our ratios as far as mass or moles go. First question says how many moles? So that's when we're going to use these, okay, for moles. All right, if they want to ask for, if they're asking about moles, then we need to look at the mole ratios. All right, so we want to know how many of H2, how many moles of H2, okay, out of, in our general equation, 3 in the original recipe, is going to equal And I don't know why my pen is not working for me today. 6.5 moles of NH3, where the original recipe yields only 2. So we cross multiply, and we get 2x is equal to 6.5 times 3, which is 19.5. moles. Okay, divide that by 2. And this will give us the number of moles. Divide this by 2, we get 9.75 moles required. Okay? Next question. Now it says how many grams? So we're going to use the gram information that we have. Okay? So it says how many of NH3, how many grams of NH3, and then let's go back up and say how many grams are produced. 34 grams in this entire reaction. Okay, are produced if we use 50 grams of N2. In the general recipe, how much is used? Only 28 grams. Okay, of N2. Okay, so there's my ratios, and then we're going to cross multiply, so it'll be 28x equals 50 times 34, which is 1,700. Large number, but we're going to divide by 28, and we will get about 60.7 or 61 grams. All right, we'll make it sig figs. All right, so let's do 61.0 grams of NH3 are produced when we use 50 grams of N2 gas. Okay? The end. If you have any questions on this unit, please practice using or doing the practice questions for the test, okay, the practice test in class, and study those, and you should be all set. Not focusing a lot on Avogadro's number or using the 22.4. Just know how to convert it if they ask about liters, liters or milliliters, then there's a conversion with the 22.4, okay? Or if it says molecules or atoms, then use 6.02 times 10 to the 23rd, okay? So I like to just throw that stuff in there for you guys. All right, happy studying, guys.